In this video, we're going to talk about prime and composite numbers. Before we get started with figuring out these two problems that we have over here to figure out if these numbers are prime or composite, I want to fill out this chart here to help you recognize all the prime and composite numbers between 1 and 100. So the first prime number by definition is 2. So I'm going to circle that one. And what I'm going to do is I'm going to cross out now all the multiples of 2, because anything that has another number that multiplies to give you that number, another factor pair other than 1 in itself, is a composite number. If something can only be multiplied by 1 in itself to get that number, like 2 is only 1 times 2 or 2 times 1 to get 2, that's a prime number. So 4 can be broken down again into 2 times 2. So that's going to be composite. 6 is 2 times 3, 8 is 2 times 4, and so on. And I'm going to get rid of all the numbers that end in 0, 2, 4, 6, or 8, because they'll all be even numbers. So that'll work out that every other number, every second number on my chart has been eliminated. We're going to see something neat here, that by the time that I'm done with the first row and eliminating numbers based off of the first row, that I'm going to be done with the whole chart, because the chart is a square. So I'll be done with all 10 rows and 10 columns as soon as I'm done with the first 10 columns made up by the first row here. All right, that got rid of a lot of them here. Now the next number that's not crossed out is the next number that we're going to circle. 3 is the next prime number. And now I'm going to cross out every third number, every multiple of 3. So we've already crossed out 6. Need to cross out 9. We've crossed out 12. I need to cross out 15. We've crossed out 18. Need to cross out 21, and so on. You see every other multiple of 3 is going to be one that we're going to need to cross out. 5, 51, 457, 60, 63, 66, 69, 275, 78, 81, 84, 87, 90, 93, 96, 99. All right, then the next one is going to be 5. And you know your multiples of 5, they all end in 5 or 0. So we're going to cross out all the ones that end in 5 that are left. We've already crossed out all the ones in 0 because they were multiples of 2. And that means 7 is our next prime number. So 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, and 98. Yep, 98. There we go. Everything that's left now, I'm going to tell you, is a prime number. So 11 is prime, 13 is prime, 17 is prime, 19 is prime, 23 is prime, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Now that we have all of that done, I might go ahead and highlight these that are prime to help you find them a little more easily. There we go. I think that's all of them. So now let's come back over here and let's see if we can identify 97 as prime or composite. Well, 97 is right there and it's circled, so that's a prime number. 26 over here is crossed out. It's got to be composite. Now let's talk about how we know 26 is composite. 26 is composite because we know 2 goes into it evenly since it ends in 0, 2, 4, 6, or 8. So if we divide it by 2, 2 times 13 is 26, as well as 1 times 26 is 26. So it's got multiple ways it can be broken down. The only way that 97 can be broken down is 1 times 97 or 97 times 1. There are no other ways to break 97 down. All right, that's it for this video on prime and composite numbers. Just 2 examples here. We're going to come back next time and we're going to talk about the prime factorization of a number. So we're going to break down composite numbers into their prime factors. So we'll be using this chart again to help us know what prime numbers are so we can find the prime factorization of a number. All right, see you for the next video.